Hi students, today we are going to discuss about cache memory. Okay, it is an important memory in the our memory hierarchy. First, you have to understand how these memories are arranged. Okay, here is the CPU registers. Here is the CPU registers. Then cache memory, then main memory, then disk cache, then disk. Okay, these are secondary storage. Okay, these are primary. Okay, first of all, the CPU register and cache memory. Okay, CPU register and cache memory both are inside the CPU, okay, or inside the processor. The register memory and the cache memory both are inside the CPU. Okay, then move towards how it works. First of all, when CPU need any address or data, you have to understand that if this is a CPU, then CPU, sorry, this is, if this is a cache, then cache memory has two parts. One is instruction part, another is data part. Okay, one side it stores the instructions, one side it stores the data. You have to first understand why the cache memory is storing the data. There is also registers. Why we can't replace the cache memory with registers? Registers work is different. Okay, register only stores the data. Okay, but the cache memory stores the frequently used data. If you are using a data frequently, or if you are using instruction frequently, as you know, our memory, main memory, can store anything. Okay, it's maybe data, it's maybe instruction. The memory don't know what is storing. Okay, that's like our cache memory only stores the frequently used data. The data may be instruction, the data may be any values. The cache memory used only to store the frequently used data. We don't need to communicate our main memory repeatedly for a single data bit. Okay, our CPU don't need to communicate with the main memory for a single data bit which you are using repeatedly. If a data is using repeatedly, then the data should be placed inside the cache memory, and cache memory is nearer to the CPU. Okay, cache memory nearer to the CPU. The CPU can access from the cache memory directly and fastly. And cache memory is so much expensive. This is SRAM type. SRAM type. Cache memory and register memory are both are SRAM, while our main memory is DRAM. We have discussed in my memory hierarchy video. Okay, cache memory is very expensive and small because it is expensive. Then here is main memory. This is DRAM. This is DRAM. Our CPU will communicate with cache. If it find the data in cache, then it don't go towards the main memory. If it don't find the data, it will go towards the main memory. Okay, you have to understand that there are levels of cache. There is levels of cache. What is the levels? There are three levels. One is L1. Yeah, another one is L2. Then another one L3. Okay, these are three different caches. Okay, size of L1 cache is smaller than compared to all other caches. Size of L1 caches is smaller compared to the L2 caches and L3 caches. Okay, and L1 caches nearest to the CPU. Okay, L1 caches is nearest to the CPU. Okay, I am making it correctly. That is easier. L1 cache nearer to the CPU. Okay, then L2 cache, then L3 cache. Okay, all the caches inside the CPU, but the L1 cache is small according to L2, and L3 is the largest cache. L3 is the largest cache. While L1 is small and L1 is faster also. L1 is faster than all this. Then L3 and L2 cache. CPU have to first search in L1. If it finds L1, then it's best. If not find, then check L2. If not find, then check to L3. If not find, it's go to main memory. Main memory. Okay. CPU will first check the L1 cache, then L2 cache, then L3 cache. From where it find the data, it will take. There is two terminologies. One is hit and miss. Okay, hit and miss. Okay, you have to understand first. There is two things. Hit, also called cache hit. Cache hit. Another one is cache miss. Okay. What do you mean by miss and hit? If the CPU find the data inside the cache memory, then it's surely a cache hit. Okay. If the data is not inside the cache, then it's a cache miss. Okay. If the CPU requesting a data and the data or instruction not inside the cache, then it's a cache miss. Okay, here is some hit ratio. Hit ratio means from let's our CPU requested 3 instructions. Then how many instructions got hit and how many instructions got miss? These are, by this we are calculate hit ratio and miss ratio. Okay, hit ratio and miss ratio. There is 10 instruction CPU 10 instruction CPU requested. Okay, or 10 data or anything, 10 data or instruction our CPU are requested, but only 7 hit and 3 miss. Then the ratio must be 0.7. How? 7 hit divided by our total request sent, total requested, it's 0.7. This is the hit ratio. Okay, and like that, if I am trying to calculate our miss ratio, then I also can calculate. How can we calculate our miss ratio? 3 by 10 is equal to 0.3. Yes, our miss ratio. Okay, here is hit time. Hit time is how many time it takes to capture the data from the cache memory. Okay, or takes the data from the cache memory. This is called hit time. Okay, when a miss occurs, the CPU have to, or the data should be come from the main memory. Okay, or other storage device, because there is no data inside the cache memory. So miss occur. If miss occur, the data should be bring from the outer device, means it's main memory. And then the data come from the main memory should be stored inside our cache memory. Then our CPU will be used. Okay. Now let's move to our diagram. How the CPU works. First of all, this is the diagram how actually CPU works with the cache memory. Okay. Actually, here is also a device called MMU, Memory Management Unit. Okay, Memory Management Unit. Okay, connected to CPU and cache memory. Okay, Memory Management Unit. What is the work of memory management unit? Okay, a memory management unit actually search inside the cache. Okay, accelerate the search inside the cache that the address is available or not, If not available, it brings forward. Okay, let's ignore our memory management unit. First, look at the diagram. A CPU send a signal, then go to the cache memory. Go to the cache memory. If the data is inside the cache memory, then it disable the buffers. Means no need to search at the main memory. Okay, no need to access these buses, these registers, address register, data register. No need to address, because here is the data. Okay, because here is the data. Okay, but when there is a miss, the CPU requested some signal and sourced in data. Okay, then there is a cache, but no data. This data is not inside the cache memory. Then it will active the buffers, the data buffers or address buffers. Your buffer enabled. Okay, then the data will be further sourced inside our main memory and taken to the CPU. Okay, this is our simple cache operation. How we are operating with our cache memory. Okay, there actually other things also happen. There are also a logical address and physical address. Logical address and physical address. Physical address. Two types of address works. CPU send the logical address. CPU send the logical address. Okay, and then from the logical address, then our memory management unit convert the logical address into physical address. Okay, and search in the main memory. Okay, this is clear. Okay, so this is the method. This is how our cache works, and we will discuss about other things. Here is also our cache write. Here is also our cache write. Okay, first of all, you have to understand that our data is not sourced in the cache. Okay, our data is not sourced inside the cache. Okay, our system source the address of the data. Okay, CPU send the address. Okay, keep the data is this in this address in main memory is needed. Okay, the address is needed inside the cache memory. Okay, if the address is found, then there is a cache block where the address is related to the cache block. Then the data from the cache block will be taken to the CPU. Okay, we never, or our system never search the data inside the cache. It searches the address also. Always it searches the address. First of all, you have to understand how a cache block looks. This is a cache block. Okay, this is a cache block. This is tag. Then this is data. Okay, and this is a metadata bit. Metadata bit. Okay, you can say what is the work of metadata bit. Metadata bit actually stores some information about this cache block. Okay, this cache block is inside the cache memory. Okay, this cache block is inside the cache memory. This cache block is not requested by the CPU. Okay, CPU. Okay, just move towards what is tag. Tag means it hold the address. Okay, it hold the address of main memory. Okay, it stores the address of main memory. Then our CPU search the address of main memory inside the cache memory. If the address is available, then the data is available, then there is a cache. Okay, we will read next video about more about the cache mapping and how cache write operations done. Thank you.